Kia ora and welcome to this short video on relative dating, one of the few techniques that we'll look at this year in terms of how we geologically date things. We're going to start looking at this technique as a whole and recognise the main types of these things called unconformities. And then we're going to apply all this new knowledge we learned to a little diagram. So let's crack on. Now, there's a few rules that relate to relative dating, so we need to look at those first. And this first one is the law of superposition, which states that in an undeformed, undistributed sequence of sedimentary rocks, each bed is older than the one above it and younger than the one below it. Now, this is important to remember that if you've watched or rewatched the sedimentary video, you'll know that all sedimentary rock is put down in layers and they're always flat. And the youngest layers will obviously therefore be on the top as they're laid down last, and as you get lower and lower, the oldest ones will be towards the bottom, obviously due to gravity. Now, uniformitarianism is the process that has happened in the past and that can happen today, and those are things like volcanic eruptions, erosion, and fault movement. What we're also looking for is unconformities, which are things that are missing from the usual pattern that we'd expect to see of this laying down of flat layers. Again, that's usually due to an external factor such as erosion. So we're going to look a bit at the internal factors and external factors here today. So, what are some of these internal factors that we've got to bear in mind? Well, obviously remember our plate tectonic movement. This can obviously cause a few events to occur, namely volcanoes are a big one, and you can see here some examples of intrusion. And intrusion is when our magma comes up into the faults between the layers and alters the way they are laid down. But you've got to remember, all of these are always laid down first. The layers are always there to begin with. And second, we've got our faults that cause cracks and movement within our layers. So that's something else to be aware of when earthquakes occur. And finally, we've got our folding of rock. And this usually happens down here, much closer to the mantle, where the superheat starts to manipulate the layers. And obviously, we've got magma coming up here. Igneous rock starting to try and protrude its way through. So that is something to also be aware of that can cause changes in our beautifully flat layers being laid down. Now, when we're looking at a rock face and trying to determine its date, there are three main things we need to look at. And when we look at this layer, we expect it to be like a book. So you've got all the pages in order, and you expect it to be nice and neat and flat. However, you kind of can notice sometimes when the pages of the book are missing. You know, if there's a big chunk missing, the book will start to change shape. It won't be square. You know, the pages might start to slant slightly compared to the bottom layers. And that's what we're going to look at here today with these three types of unconformities. First one being angular unconformity, then disconformity, and then nonconformity. Excuse me. So we've got to remember that erosion, the external factor, is a big thing that can occur here, as well as the other internal factors that we've just looked at. And we're looking for this correlation of rock sequences by comparing all these layers. And once we compare all these layers, we should be able to generate a complete record, even if some of those layers are missing. So what am I actually talking about? Well, here's a picture to show you. Here's the different types of unconformities. So in this one, we're actually going to look at angular unconformity. So horizontal sedimentary layers are tilted when they are uplifted and then eroded. So sometime in history, we've got here the tilting and the uplifting. You can see the movement up here. And then they've been eroded at some point at the top, and then new layers are deposited on top of that eroded surface. So we look for these angles or changes in angle from our flat stereotypical sedimentary layers, and that will give us the idea of this angular, because the angle's unconformity. And here's what it looks like in real life. So you can see here we've got a clear angle, that way. And then where the line is here is where there's been some erosion and some new sedimentary rock up here laid down. So that's a really good example of that in real life. Next we've got disconformity. Now disconformity is this one down here, and in this one we can clearly see that the sedimentary rocks were lifted and eroded again here on either side, and the new layers were added on top, but all the layers are parallel. So this was just obviously some form of external factor that was wearing it down, maybe a water stream of water causing just a bit of erosion over time that then stopped, and then all our new layers were layered down parallel on top of that. So we see a gap in the rock record here, but we can work it out based on what's either side. And this is an example of it in real life. So you can clearly see here the two layers of the different layers of the rock and the nice dip due to some erosion over time, be it wind, ice or water. And finally we've got nonconformity. Now nonconformity is slightly different, and it looks at our other two types of rock. So if I'm saying the words igneous and metamorphic and you're not knowing what they are, I've got two videos, one on each of those, for you to have a quick review of soon. Now, igneous and metamorphic rocks, in this case, these ones down here, have been uplifted. As you can see, they're different and not horizontal layers like the sedimentary, and they have been eroded over time, and then our sedimentary rocks have been deposited on top of these. Now you can clearly see two different types of rock, and when there's two different types of rock, that is what's called a nonconformity. Now, we're not going to look at this one today, this is a bit different, but this is to do with a bit of introduction of some biology in life to the whole unconformity situation. Now let's have a look at some nonconformity in real life. So here, pause the video and see if you can draw the line on where you see the nonconformity. Okay, I think you know where it is. Alright, so here we've got clear layers of sedimentary rock, very clear, very definite. But down here we've got this very different type of rock, and as you can see by the little blurb, it's actually granite down here, followed by our sandstone up the top. So there's an event that occurred that caused this granite to be uplifted and eroded over time, and then the sandstone to be the one on the way. So there we have it, an introduction to relative dating, using our eyes and our knowledge of the internal and external forces that affect our landscape. And now I want you to make sure you've got that worksheet that you've been filling in, and on the back you'll find the instructions for this diagram to fill in all those circles and add 3 other things, and all the information to do that has been given to you in this video. So good luck. Make sure you write down lots of questions that you need to ask me in class, and if you don't have any clarifications, then crack on with the worksheet and I'll give it a mark. I'll catch you in class. See you later.